Friends, welcome to Bank Exam Cafe, and in today's episode we are going to solve few more questions of 1 mark, and this is the part 8, and previously we have uploaded 7 parts, and I request you to see all these 7 parts so that you will get an idea that how to solve 1 mark questions and which type of questions will be asked as the 1 mark questions. I also request you to download the study material from the description box. So friends, let us move to the first question of today's episode. If alpha and beta are the zeros of the quadratic polynomial p of x is equal to x square minus p into bracket x plus 1 minus c such that into bracket alpha plus beta close the bracket into another bracket beta plus 1 close the bracket which is equal to 0, what is the value of c? Friends, here the given polynomial is what it is, x square minus p into bracket x plus 1 minus c. Multiply by p inside the bracket and write this quadratic polynomial in a standard form. So it will be x square minus px minus p minus c. This will be the standard form. So here a will be equal to 1, b equal to minus 5 and c will be equal to minus p minus c. And it is given that into bracket alpha plus 1 close the bracket into bracket beta plus 1 close the bracket is equal to 0. So here we will use this, that alpha plus 1 into another bracket beta plus 1 which is equal to 0. Now here multiply these two brackets. So multiply by alpha first to this bracket, so it will be alpha beta plus alpha into 1, that will be alpha. Now multiply by 1 to this bracket, so it will be 1 into beta will be beta and 1 into 1 will be 1 which is equal to 0. Now from this we can find the product of the roots and the sum of the roots. So from this we can find the product of the roots as alpha beta which is equal to alpha beta is equal to c upon a. So c upon a, that is minus p minus c upon a, that is 1, and therefore alpha beta that is equal to minus p minus c, and the alpha plus beta that is equal to minus b upon a. So b is what? Minus p. So minus and minus will be plus, so it will be p upon 1, that is equal to p. So put the values here. So alpha beta, put the values here. So alpha beta is minus p minus c minus p minus c. Then alpha plus beta, sum of the roots is what? It is p. So it will be plus p plus 1 which is equal to 0. So this p and p will get cancelled. Minus c plus 1 is equal to 0. Take c to the other side and you will get c is equal to 1, and therefore the value of c, that is equal to 1. Highlight this. Now move to the next question. If alpha and beta are the zeros of the quadratic polynomial f of x is equal to ax square plus bx plus c, find the value of 1 upon alpha plus 1 upon beta. Here the given quadratic polynomial is ax square plus bx plus c, and we have to find the value of 1 upon alpha plus 1 upon beta. So 1 upon alpha plus 1 upon beta, that can be written as alpha beta will be the LCM. Multiply here by beta and here by alpha, and so it will be beta plus alpha. and beta plus alpha is nothing but alpha plus beta. So this is the sum of the roots, this is the product of the roots, and from this quadratic polynomial we will find the sum of the roots, that is alpha plus beta, that is equal to what? Minus b upon a, minus b upon a, and alpha beta, that is equal to c upon a. So it will be c upon a. Put these values here and you will get sum of the roots, that is minus b upon a, minus b upon a, upon alpha beta, that is c upon a. So this a and a will get cancelled and it will be minus b upon c, and therefore 1 upon alpha plus 1 upon beta, which is equal to minus b upon c. Now move to the next question. Write whether the following pair of linear equations is consistent or not. The two given equations are x plus y is equal to 14 and another equation is x minus y is equal to 4. So to state whether it is a consistent or not, the pair of linear equations is consistent or not, we have to find the ratio of the coefficients of x, that is a1 upon a2, that will be equal to 1 upon 1, so it will be 1. And we also find b1 upon b2, that is equal to, this is b1 upon b2 means the ratio of the coefficients of y, so it will be 1 upon minus 1, so which is equal to minus 1. Here only we come to know that a1 upon a2 is not equal to b1 upon b2, so the ratio of the constant there is no need to find. So here we get a1 upon a2 is not equal to b1 upon b2, and since these two ratios are not equal, we say that the pair of linear equations has unique solution. The pair of linear equations has unique solution and therefore it is consistent, and therefore the pair of linear equations is consistent. Now let us move to the next question. Write the nature of the roots of the quadratic equation 4x square plus 6x plus 3 is equal to 0. We have to write the nature of the roots. The nature of the roots we have to write, it means what? Whether it is no solution, whether it has distinct solution or it has unique solution, that we have to state. So the given quadratic equation is 4x square plus 6x plus 3, which is equal to 0. Now here we will first find d, that is the discriminant, and the discriminant is given by the formula b square minus 4ac. So here b square, that is b is a coefficient of x, that is 6, and 6 square will be 36, minus 4 into a is a coefficient of x square and here it is 4, so minus 4 into 4 multiplied by c is a constant term and that constant term is 3, so which is equal to 36 minus 48. 4 4s are 16, 16 3s are 48, and therefore 36 minus 48, that is equal to minus 12. And since the discriminant is negative, that discriminant is less than 0, and since it is less than 0, it will have no solution. The quadratic equation has no solution. Here also remember that if d is equal to 0, I revise this also, that if d is equal to 0, then the given quadratic equation will have unique solution. It means it will have same values, same roots, and d is greater than 0, then it will have distinct roots. Distinct root means what? Different roots. Both roots will be different. And if d is less than 0, then it will have no solution. the given quadratic equation will have no solution. So for d is equal to 0, it will have unique solution. D is greater than 0, it will have distinct, it means different solutions, and if d is less than 0, it will have no solutions. Now let us move to the next question. If the sum of the first p terms of an AP square plus BP, find its common difference. It is given that the sum of the first p terms of the given arithmetic progression is what? AP square plus BP. So here the sum of the p terms, that is equal to what? AP square plus BP. Now here therefore the sum of the first term will be what? Put the value of p as 1, so 1 square will be 1, and so it will be a plus, here you will put 1, so b into 1, that will be b. Sum of the first term, that is equal to a plus b, and sum of the first term, it means what? It is the first term only. So the first term of the given arithmetic progression will be a plus b. Now the sum of the first two terms we will find. So sum of the first two terms will be what? Put the value of p as 2, so 2 square will be 4, and so it will be 4a, plus put the value of p as 2, so it will be plus 2b. So here this is the sum of the first two terms, and therefore the second term will be what? The sum of the first two terms minus first term, so it will be 4a plus 2b minus a minus b, and so this will be equal to 4a minus a will be 3a, and 2b minus b, 2b minus b, that will be plus b. So this is the first term we are getting as a plus b, and the second term is 3a plus b, and therefore the common difference, that is equal to a2 minus a1, and so it will be 3a plus b, 3a plus b minus a minus b, correct? Minus a minus b. So b and b will get cancelled, 3a minus a, that will be 2a, and therefore the common difference of the given arithmetic progression is 2a. Now see the next question. In the figure, angle M and angle N is equal to 46 degree. It is given that this angle M and this angle N is 46 degree. We have to express x in terms of A, B and C, where A, B and C are the lengths of LM, MN and NK respectively. So MN is what it is, LM is what it is A, L, M, this is A, then MN, that is B, MN, that is B, this distance is B, and NK, that is equal to C, NK is C, and we have to write the value of x in terms of A, B and C. And here friends, Pn is x, the length of Pn is x, and we have to find the value of x in terms of A, B and C. Here we see that this angle and this angle are equal. So if we take this triangle PNK and triangle KLM, in these two triangles we see that this angle and this angle are equal given, and this angle K is common to both the triangles, this triangle as well as this triangle. So this is common, and therefore by A criteria these two triangles are congruent, and therefore the ratio, similar, and therefore the ratio of their corresponding sides will be equal. So first we will write up to this. So in triangle LMK and triangle PNK, we have angle M is equal to angle N, which is equal to 46 degree, and this is given. and this angle K is equal to angle K because it is common, and therefore these two triangles, and therefore triangle LMK is similar to triangle PNK. Reason will be what? AA criteria. And since these two triangles are similar, the ratio of their corresponding sides will be equal, and therefore LM, its corresponding side is PN, so LM upon PN, that is equal to MK upon NK, MK upon NK, which is equal to LK, its corresponding side is PK, so LK upon PK. And so here put the values. Here LM is A, so A upon PN, that is X, which is equal to MK, that will be B plus C, so it will be B plus C upon NK, NK is what? C. Now take X to the other side, take AC to other side and B plus C to other side, and therefore you will get X is equal to AC upon B plus C. So here we have got the value of X in terms of A, B and C, as X is equal to AC upon B plus C. Now move to the next question. If 3 tan theta is equal to 4, find the value of 5 sin theta minus 2 cos theta upon 5 sin theta plus 2 cos of theta. Here given that 3 tan of theta, which is equal to 4, it means tan theta is equal to 4 by 3. Now here first thing that can we convert this into tan theta so that it will be easier to solve. We know that sin theta upon cos theta, that gives us tan theta. So if we divide the numerator by cos theta and also the denominator by cos theta, then what we will get? 5 sin theta upon cos theta minus 2 cos theta upon cos theta, that will be 1. So I write here cos theta upon cos theta, that will become 1 upon in the denominator again the same thing, 5 sin theta upon cos theta plus 2 cos theta upon cos theta. Now here we have divided the numerator by cos theta and denominator also by cos theta, and so here sin theta upon cos theta, that is tan theta, so 5 tan theta minus cos theta will get cancelled and you will get 2 upon 5 sin theta upon cos theta, that is tan theta, so 5 tan theta plus 2. Now here tan theta is what? 4 by 3. Put the value of tan theta here as 4 by 3, so 5 into 4 by 3 minus 2 upon here it will be again 5 multiplied by 4 by 3 plus 2, and therefore this will be 5 4 that 20 upon 3 minus 2 upon 20 upon 3 plus 2. This we can solve further, as is equal to 3 will be the LCM, so 3 2s are 6, so 20 minus 6, so 20 minus 6, that will be 14, and this will be 3 2s are 6, 20 plus 6, that will be 26, and this we can divide, that 2 7s are 14, 2 1s are 2, 2 3s are 6, and that is equal to 7 by 13. So friends, here now we will stop. I hope you must have enjoyed this video. If yes, please like the video, share it with your friends, and do not forget to subscribe the channel. Thank you very much for watching this video.